Hello, everyone, and welcome to the latest episode of Fabric Espresso. My name is Filip, and today we'll talk about Fabric Warehouse performance best practices. Now, Fabric Warehouse provides you with a great performance out of the box. It does so by making sure that the data that you ingest into Fabric Warehouse is always in the best shape for optimal querying. It also automatically scales for you, meaning that it provides the amount of resources needed to a query for optimal execution. However, there are some small things you can check in your workload to squeeze that last drop of performance. And then there are some things that are out of control of the engine. For example, the location of your data, or for example, maybe you're querying tables that are not ingested in the Fabric Warehouse, so maybe it's not in optimal shape. And we will discuss how you can get the best performance there as well. Let's start with the collocation of your resources. Fabric Warehouse is software as a service, meaning the compute is somewhere in the cloud in some Asia region. And when you execute a query, in order for data to be processed, it needs to be read from the storage and brought where the compute is. Your compute is in the region where the capacity is. So when you attach the capacity to the workspace, you define where the compute is located. When you ingest the data is ingested into the same region where your compute is. And when you query that data, you get the best performance because network latency is so low because the data is in the same region where the compute is. You can also create shortcuts to query data in AWS Gen 2 storage account in the same region, for example, or maybe shortcut to a lakehouse table in a same region. In those cases, your performance will be great. However, you can create shortcuts pointing to AWS Gen 2 storage accounts in a remote region, and you can create shortcuts pointing to some other clouds like Amazon S3 or Google Cloud Storage. In those cases, data needs to be read from the remote region, from different parts of the world, and to be brought where the compute is for processing. In that case, you may experience some performance overhead. Now, I'm not saying that you should not use shortcuts. Shortcuts are awesome. Shortcuts are really, really great. They allow you to query data directly from where it is and join with some other warehouse table or a lakehouse table or whatever you need to do. It literally enables you to have a single copy environment. However, you should be mindful about this potential network overhead in transferring the data. So if you suffer from bad performance or you want to get your performance better, you might consider to move large tables into the Fabric Warehouse and maybe keep those reference tables where they are and use shortcuts to access them. You can access Fabric Warehouse from anywhere in the world. You can access it, for example, from your local laptop, and there you can use browser to access the Fabric Web UI, or you may use SQL Server Management Studio or Azure Data Studio to write and execute queries. Please be mindful that your queries may return large amounts of data, and in that case, it may take some time because data needs to be transferred from the region where the fabric is to your local laptop. If you are looking for low latencies, please use SMS and ADS because Fabric Web UI uses non-binary protocol to access Fabric. It uses an API, while SSMS and ADS use binary protocol to communicate directly with the Fabric. So obviously, Fabric Web UI have a slight overhead compared to SSMS and ADS. Let's talk about your data model. First and foremost, your model needs to accurately represent the real world scenario. And only then, if you're not happy with performance, you can check data types and maybe further optimize. Use smallest data type that accommodate values. For example, you may have a column year defined as a big int. While that's fine, it'll probably work fine. Big ints can hold a huge range of integer values, and you probably don't need that big range for a column like year. So you should consider using year int or even small int. Small int should be quite fine in terms of ranges of values. If you're using decimals, you should specify precision and scale, such precision and scale that accommodates your values. Use proper data types. For example, if you know that date times will be stored, use datetime to a column. Do not use the character column and then store a date and a time there in a string format. If you know that your column will not have characters, Well, don't use a character column, use integers, for example. If you have a character column and you know that your column values will not have fixed lengths, or most of them will not, then use a varchar instead of char. If you know that the values in a character column will not be longer than certain length, then please specify the proper length instead of using the largest possible supported length. It means, for example, if you have a name, probably varchar 50 is good enough to hold each and every name that exists, instead of using varchar 8000. That being said, string improvements are planned for a Fabric warehouse and they're planned for this year, as you can see in a public roadmap. If you are using some tool to create the tables for you, for example, some tool to ingest the data, please make sure that you check the data types that that tool used to create table columns. Just like John showed us in a previous episode in a case of pipelines. We mentioned already that Fabric Warehouse automatically maintains tables that you ingest into Fabric Warehouse, meaning you do not need to care about the number of files, sizes of files, quality of groups, and so on. But Fabric Warehouse allows you to query tables that are not ingested into Fabric Warehouse by using shortcuts. So you can have shortcuts to lakehouse table or a shortcut to any table that is created by any other engine. In that case, table layout and storage might not be in the best shape for optimal performance. And Fabric Warehouse cannot optimize it because the table is not under Fabric Warehouse control. Still, there are some things that you can do there. You can use Fabric Warehouse to query tables that are not ingested into Fabric Warehouse. So, since it is the same engine, just this time reading other tables, tables that are not ingested into Fabric Warehouse, still the same rules apply, the same best practices. Let's start with checking the data types. Since same rules apply, I would say that here, when querying lakehouse tables or tables produced by other engines, the most important thing to check is how character columns are defined. Lakehouse users are not used to specify character column lengths, as you can see in this example. The same applies to PySpark users as well. And this results in having a character column without defined maximum length in the metadata. Here we have a PySpark script that inspects the metadata to confirm that it is defined as a string type, but there is no any metadata telling us what is the maximum column length. Since there is no maximum column length, SQL engine sees this column as a column of maximum supported length. This can negatively impact query performance, and here's how you can define a character column with specifying maximum length for that column using sparse SQL. So it's pretty much the same as in SQL Server. And if we take a look again at the metadata of this column, we can see that in the metadata, we can find the length of a column. Since maximum column length is defined, we can see that SQL is able to recognize it. Now, you probably noticed that we defined the column as varchar 5, but Warehouse sees it as varchar 20. The reason is simple. When you define a maximum column length in Spark, you specify maximum number of characters. When you're specifying the maximum column length in Fabric Warehouse, you specify the maximum number of bytes. And since delta is used, underlying there is Parquet uses UTF-8 encoding to store strings. In UTF-8 encoding, any character, Latin, Cyrillic, or emojis, can take from 1 up to 4 characters. So in order to be able to make sure that Fabric Warehouse can read properly 5 characters that are encoding with UTF-8, we need to define it as varchar 20 bytes in the case of Fabric Warehouse. After you checked data types, particularly strings, please make sure that the table is optimized. Optimize statement is used to optimize the layout of the table in the storage, meaning to make sure that the number of files is good and that the file sizes are more or less equal. So when do you need to optimize the table? Well, whenever it changes significantly or after some period of time. You can take, for example, an extreme example, which is streaming, meaning that at the high throughput, the rows are being ingested in a very, very small batches, probably just one row at a time, meaning that one insert, one row results in one transaction, resulting in one new file. So number of files can easily add up. And then the engine struggles opening the files from the storage, reading the metadata, and probably spends more time there than actually reading the data and processing the data within those files. So with Optimize, you make sure that the number of files is not that big and the files themselves are of larger size, hence much better for optimal querying. So when it comes to reading tables using shortcuts, including lakehouse tables, you need to make sure that the proper data types are used and that the table is optimized. If you're not happy with the performance, then you can consider partitioning the table. So if you are often querying the table and using the same columns in a where clause, you can consider partitioning the table. You partition table by those columns that you often use in filters, and in that way you help the engine dramatically reduce the I/O. It's easy to partition the table. When you create it, you need to specify specify a partition by clause and specify columns that you want to partition this table on. This will result in rearranging rows in a storage in different set of files. So without partitioning, you will have all files for this table in one folder, while when table is partitioned, for example, by column year, you will have folders year equals 2016, year 2000 equals 2017, and so on. And there you will have only files that contain value rows with where this column year has values 2016 or 2017. This helps the engine to dramatically reduce the I/O to read only files from specific partition that you're interested in. Here we have a query, simple one, that counts rows from the table that is not partitioned and counts only rows from specific year and month. This query finished in 32 seconds because it had to scan billions of rows and to apply a function year and month to each one of it. The same query, just this time when targeting partition table, will take only 2.6 seconds. So obviously we got a dramatic performance improvement by reducing the I/O. If you still need better performance and you have some columns that you often use in filtering, but not out of those partitioning columns, you can consider set ordering your table by those columns. So what is set ordering? Set ordering is rearranging the rows in a way that ranges of values it's highly unlikely for ranges of values to overlap between row groups and files. You can think of it something like sorting on specific column, but not exactly sorting. How does it help? Well, when the engine reads Parquet files are consisted of row groups, and each row group contains a set of rows, obviously, but each row group has metadata about minimum and maximum column for each and every column in that row group. So when engine reads the file, it reads the row group metadata and can decide whether it should read or should just skip that row group based on your where condition. This way, we also reduce the I/O. It just works differently than partitioning. Here we have a query that also counts the rows, but it uses a different column for filtering, so not a partitioning column. And this table is neither partitioned nor set ordered. This query took almost 10 seconds. We can set order this table. We use the same optimize statement, provide the name of a table, and then we specify set order by keyword and specify one or more columns that we want the table to be set ordered by. Please know that the impact of set ordering is the positive impact on performance is the largest for the first column that you specify. If you specify more columns and filter by second or third, well, data is set ordered by the first column first, then by second, and then you cannot expect as much of performance improvement as when filtering on the first column that you specify here. This time we have a query that also counts rows using the same condition as previously, targeting the same column, but this time table is set ordered. And this query took only 2.5 seconds. So what we did here is that we applied set ordering and reduced the duration of a query from 9 plus seconds to 2.5 seconds. So, while Fabric provides you with a great performance out of the box, we showed how you can tweak your workload to squeeze that last drop of performance. We also discussed how location of your resources, where your tables are compared to where your compute is, can impact performance. We mentioned that using the tool on your local laptop introduces some overhead because of the network transfer when you are returning the large amounts of rows. Then we discussed how you can optimize performance with querying data that is not ingested into the warehouse. So lakehouse tables, or using shortcuts to query any other table that was produced by any other engine. And you can do that by checking the data types, of course, primarily the lengths of character columns, then optimizing the table to make sure that the layout and the storage is in a best shape for optimal performance, meaning number of files and sizes of files. That should be done on a regular basis, depending on the rate of changes of your table, inserting, deleting, and updating rows. And then if you have some columns that you often filter on, you can partition the table in Lakehouse. And finally, you can also set order the table by some columns, some additional columns that you want to filter on or you filter on often. Now, please note that partitioning is supported in a Lakehouse as operation on a table, but partitioning is not supported in a warehouse. So you cannot partition a warehouse table because warehouse provides the performance, great performance out of the box. However, Fabric Warehouse allows you to read partition tables that are created by other engine. And as a reminder at the end, please take a look at our previous episode where John talked about ingestion best practices. If you like the content, please share, like, and subscribe. If you have any questions or comments, please let us know in the comment area. As usual, this was Philip. Bye.